All right, welcome to this lesson on 2-4. We will be talking about complex numbers and operations with complex numbers. So the essential question, how can you represent and operate on numbers that are not on the real number line? So we're not dealing with real numbers here. So how do we solve problems with complex numbers? So the standard is that we have to know that there's a complex number I such that I squared is equal to -1. And every complex number has that form. So let's get a little bit more into complex numbers. So this is the vocab that you need to know. You need to know what a complex conjugate is, complex number, imaginary number, and the imaginary unit I. So let's look at the first example. Let's solve a quadratic equation using square roots. So remember that a quadratic equation is an equation with 2 as the highest power, right? So we know this is quadratic. Now normally what we would do is, in the previous lesson, we would move the 16 over to the other side, right? And then you would get, x squared minus 16 equals 0. And then you would factor this guy, right? So you would factor this guy. So you need to find the factors of -16 that add up to 0, which is 4 and -4. And then you can factor this into x plus 4, x minus 4 equals 0. And then use the zero product property, right? So the only thing that makes this 0 is x equals -4. The only thing that makes this 0 is 4. So you can solve it using this way. However, we want to solve it using square roots. So this is how you solve it using factoring. So if we want to actually, so this is like the factoring method. Now, if we want to solve it with square roots, all we got to do is, well, we got x squared by itself. We can take the square root of both sides to get rid of the squared, because square root and square are opposite operations. So whatever we do on one side, we have to do on the other side. However, every time you take a square root, you need to include a plus or minus in front of the square root. And that's because, if you square a negative number, you can also get a positive number out of this. So if we say x, so now the square and the square root cancel. So now we got x is equal to plus or minus square root of 16. All right, which in this case, square root of 16 is 4. So we got plus or minus 4. Again, the reason why we include the plus or minus is because we know that 4 squared is 16, but -4 squared is also 16. So that's why we have both answers. So notice we get the same answer regardless of whether we do factoring or whether we do the square root. So in this case, it's easier to just do the square root property just because, it's only one step. Now for this one, you can do the same thing using square roots, right? So if you were to use square roots here, well, we gotta get rid of the squared in front of the x, so do the square root of both sides. Again, don't forget to include the plus or minus. So now we got x equal to plus or minus square root of -9. Now, this right here, there is no real number that multiplies to get to -9, right? Because if we were to do 3, well, 3 squared is 9, and -3 squared is +9. So there's no way to get -9 from these numbers. All right, so because there's no way of getting -9 from these numbers, we introduce a new number system known as the complex numbers. So that's where we're going to head to next. So using the solution here, well, we break the square root of -9 into square root of 9 and square root of -1. And then we know that square root of 9 is 3. So we end up getting x equals plus or minus 3 times square root of -1. And what we do is we have a new number system where this exists, and we call it I. So this is the imaginary unit or imaginary number I. So this is part of the complex numbers. So the complex numbers include the real numbers, and complex numbers have imaginary numbers in them. And these imaginary numbers are based off of square root of -1. So now we can rewrite this as x equals plus or minus 3i. So we replace I with square root of -1. So now we have a way of representing these numbers without having to worry about the square root of negative numbers. So now let's do a quick review of complex numbers. So complex numbers, again, it's a number system, kind of like the real numbers, where it includes the imaginary numbers. Okay, so you have complex numbers here, which includes imaginary numbers and real numbers. So what are imaginary numbers? Imaginary numbers are just numbers with the imaginary unit I in it. Okay, so like for example, 3i. That's a pure imaginary number, right? You have a number and then you have the imaginary unit I. That's an imaginary number. Well, complex numbers have both the real part and the imaginary part. So for example, 3 plus 2i. So this is the real part, and then this is the imaginary part. Okay, so complex numbers have both components. So that means that complex numbers include real numbers. So if you have complex numbers as one big number system, well, that includes real numbers. And then, well, real numbers are usually what we work with, right? So what kind of real numbers are there? Well, there's rational numbers, and there's irrational numbers. So the irrational numbers are like square root of 2, pi, e, all these things, and you'll learn about e later. But all these things, these are decimals that go on forever that don't repeat. So for example, 1.21513 dot dot dot, and that goes forever. So there's no way to represent these as fractions. So we call them irrational. Now rational are like, for example, fractions like 1/2, 0.5, 0.2. Those are rational because you can represent them as fractions. Even the whole number 3, like 3 over 1, etc. So these are rational numbers. Now inside rational numbers, the rational numbers include the integers, right? So we got integers here. All right, so for example, like -1, -2, and so on. Now the integers include the whole numbers. So we got whole numbers, such as 0, 1, 2, etc. Whole numbers. And then the natural numbers are just the positive numbers. So like 1, 2, 3, 4, dot dot dot. So natural numbers are positive numbers, positive whole numbers. Whole numbers include the natural numbers and 0. Integers include the whole numbers and negative numbers. Rational numbers include the integers as well as fractions. Irrational numbers are completely separate and are not fractions at all. Real numbers have all of these numbers combined, and complex numbers have all of these number systems combined into one. All right, so let's quickly talk about the powers of I. So now that we know that I represents square root of -1, we can do some pretty cool stuff with that. So we can take this, so if we were to do I squared, right, that's just going to be I times I. So then what is that? Well, square root of -1 times square root of -1 is basically what we're doing here, right? So basically, we're just, we're just saying we want to do this guy squared, right? So we just want to square this guy because we have 2 of them. So what is that going to be? Well, then, if you were to cancel this out, right, then you're left with -1. So I squared is -1. And then what if we were to do I cubed? Well, that's the same thing as I squared times I. And we already know I squared. I squared is -1. -1 times I is -I. And then let's do one more cycle here. So one more. I to the 4th. So that's the same thing as what we just found, I to the 3rd times I. Well, we just found I to the third. That was negative I. And now we got negative I times I. So we got a negative and then I times I, or I squared, I mean, sorry, because I times I is I squared. But we know that I squared is negative 1, right? So we got two negatives, which make a positive. So basically, you have I is square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the fourth is 1. And then this repeats over and over again. So then I to the fifth would be, in that case, just I, or square root of negative 1. So this repeats. This is a cycle and repeats. But the main important one that you want to know are these two, because this one we'll be using quite a bit, especially that one. I squared is negative 1. All right, so how do we find the sum or difference of complex numbers? It's actually quite simple. You do it the same way that you do it with real numbers. You simply add the like terms. So you combine the imaginary terms together and then combine the real terms together. So in this case, you want to combine 4. You want to do 4 plus negative 11. So you're going to combine the real parts first, and then combine the imaginary parts after. So we got plus. Now we got negative 7 plus 9i. So we're just combining the real parts. So this is going to be negative 7. And then negative 7 plus 9 is positive 2. So it'd be 2i. Very simple. All you do is combine the like terms. All right, so now for this one, you got 6 minus 2 is 4. And we got 8i minus negative 5i. So let me rewrite that part out just to be safe. So we got 8 minus negative 5i. Well, this becomes a positive, right? So this becomes 13. So 4 plus 13i. All right, go ahead and try what we just did, the skill adding and subtracting. All right, hopefully you tried the problems. Let's go over them together. So we're going to combine the like terms. We got negative 4 plus negative 2 is negative 6. We got 6 plus negative 9 is negative 3, and then with an I, and that's it. All right, now we got 3 minus negative 4. Two negatives make a positive, so this is 3 plus 4. So we got 3 minus negative 4. And then for the i's, we got negative 2 minus 1i. There's an invisible 1 in front of that I. So 2 negatives is a positive, so that becomes 7. And then negative 2 minus 1 is negative 3 with an I. All right, so adding and subtracting is very similar to with real numbers. Now let's look at the next operation. So we're going to look at the product, multiplying complex numbers. How do we do that? Again, the same deal as with real numbers, with one minor exception. I squared can be replaced with negative 1. So this guy is what you're going to be wanting to look at a lot. Okay, so if you ever have I squared, replace it with negative 1. So let's go ahead and do this. So we're going to distribute this guy. So we got negative 2.5 times 8. So negative 2.5 times 8 is going to be negative 20. And then negative 2.5 times 9 should be negative 22.5. So we got, but positive, I mean, so could two negatives make a positive. So it would be positive 22.5. And then we have I times I is I squared. So now what did we say? Well, we said to replace I squared with negative 1. So this is going to be replaced with negative 1. So we got negative 20 plus, oh, I forgot the I here, I apologize. Negative 20i, because this is a 2.5i. 2.5i times 8 is 20i. So let's not forget that I there. And then plus 22.5 times negative 1. I squared now becomes negative 1. So now this is just going to be negative 22.5. So we got negative 20I minus 22.5. All right, now we usually like to write this in standard form. So we want to put this in standard form. How does that look like? The standard form of a complex number is A plus BI. So that's the standard form of complex numbers. Okay, so we want to put it in that form, A plus BI form. So the real part is negative 22.5. So that goes first, and then the BI goes last, so minus 20I. Okay, so the I term goes last. So that's how it looks like in standard form. All right, so now let's go ahead and look at the next one. So this one is a FOIL, right? So you got to do 3 times 3 is 9. 3 times 2I is 6I. We got negative 2I times 3 is negative 6I. And then last, negative 2I times 2I is negative 4I squared. All right, so we did the FOIL part. Now remember, replace the I squared with negative 1. So we got, and then combine your like terms. So these guys, 6 minus 6I is going to be 0. So this goes away. So these cancel. So we got 9 plus 4 times negative 1. So we got 9 minus 4, which is equal to 5. All right, so notice we got a whole number out of this. We got a real number we got a real number, no imaginaries at all. So no i's. Pretty remarkable. The reason why we got just a real number and not any imaginary numbers is because we multiplied by the conjugates. So these two guys, notice that they're very similar to each other, except one has a minus and one has a positive on the inside. We call those complex conjugates. So conjugates are basically, complex conjugates are complex numbers that differ by just a minus or a plus sign in the middle. And they have the property that if you multiply complex conjugates together, you're always going to get a real number. So we'll show you that in the next slide. So the example that we just did, where we got 13, those are called complex conjugates. So they're complex numbers with equivalent real parts and opposite imaginary parts. Their product is always going to be a real number. So, and this is proven here. So these are complex conjugates. If I multiply them, that middle term is always going to cancel out, leaving me with just a sum of whole numbers or sum of real numbers. Okay, so here's some more examples of complex conjugates. All right, so go ahead and try this out. Find the product of the following two. All right, hopefully you gave it a try. Now let's go ahead and go over it together. So we have to distribute this guy. So we got 2/5 times 10, and then with an I, because that has an I in it. Now we got 2/5 times negative 5/2. So we got, and it's a negative, so we got negative on the outside. 2/5 times 5/2, and then I squared, because you have two I's there. All right, so what's 2/5 times 10? Okay, well, we write this as 10 over 1. 10 times 2 is 20. 5 times 1 is 5. So we got 20 over 5I minus. Now we multiply these across. So we got 10 over 10 I squared. Remember, replace I squared with negative 1. All right, so now 20 over 5 is 4. 20 divided by 5 is 4. And then 10 divided by 10 is just 1. So we have ourselves a double negative here. So it becomes a positive 1. All right, now write it in standard form. So we got the real number first and then the imaginary part last. All right, so now let's look at the next one. So we're going to distribute, or FOIL. So we got to do 1/2 times 1/2. Well, 1/2 times 1/2 is 1 times 1 is 1, 2 times 2 is 4, so it's 1/4. So we got 1/4. All right, now what's half of -2? So we got to do half times -2. Well, half of -2 is -1. So we got -1i, invisible 1. I'm not going to write the 1 there. We got 2i times 1/2. So half of 2 is, 1. So it's going to be positive 1i. And then we got 2i times -2i, which is 2 times -2 is -4. And then I times I is I squared. Now notice if we combine these cancel out. And we got 1/4 minus 4, replace the I squared with -1. So we got 1/4 plus 4. Now we got to combine those two numbers and we get our final answer. So we write 4 as 4/1. So the common denominator here is 4, so I need to times this by 4 because we need to combine these fractions, so we need a common denominator. So we have 1/4 plus 4/4, which is 5/4. Notice that these guys were complex conjugates, which is why we got a real number out of this. This is a real number. All right, so we will not be covering division because division is not part of the standard. We just want to cover addition, subtraction, and multiplication. Division is not terribly complicated, but it is something extra, so I don't want to cover anything that may not be covered on the exam. All right, so right, so now we're going to look at solving a quadratic equation with complex solutions. All right, so I went ahead and changed the example to 4, or instead of 5. So, okay, so if we want to solve this guy, we know there's a quadratic equation. Now, remember that there are a couple ways to solve this, right? We could solve it with factoring, and we can also solve it with square roots. So if we were to solve this by factoring, I'm going to show you both ways so that you can see how they both look like. Remember that if you want to put this in standard form, right? This can be written as x squared plus 0x plus 4 equals 0, right? Where there's no term in the middle, so we just call it 0. But now we know what b is. And if we were to set up the x table for this, right? So if we were to set up the x table, then 4 would go on top, and then 0 will go on the bottom. So we need to find two numbers that multiply to positive 4 that add up to 0. So what are those two numbers? Well, it can't be 2 and -2, right? Because 2 times -2 is -4. So it can't be 2 and -2. And it can't be 2 times 2 because 2 plus 2 is not 0. So it can't be 2 times 2 because 2 plus 2 is 4 and it's not 0. So the only way that we can do this is with imaginary numbers. So if we were to do 2i and -2i, then this would work because 2i times -2i, well, that's going to give us -4i squared. And remember that I squared is -1, so then this becomes 4. So this checks out. It multiplies to 4. But also, if you were to do 2i plus -2i, that's just going to be 0. So that checks out as well. So if you wanted to set up the x table here, the only way you could do it is with this imaginary number I. So now we could factor this. So we got our double parentheses, right? And we got x. Now that's a positive 2i, so plus 2i. And x, and then that's a minus 2i. There you go, we factored it. So then now we can use the zero product property. Remember from last lesson where you could set both of these to 0. So we have x plus 2I equals 0 for this guy, and x minus 2I equals 0. Well, in that case, you just subtract 2I on both sides. So x has to be negative 2I. So we got one of our solutions. And then this guy, you're just going to add 2I to both sides, right? So this will be x equals 2I. All right, so that's how you factor that guy and solve it using factoring. However, there's an easier way to do this, right? We can do it with square roots. So this is like the square root method. Okay, so if we want to do the square root method, okay, well, if we want to do the square root method, then we have to solve for x here. So we gotta move the 4 to the other side. So we're gonna subtract the 4 to the other side. And now we get x squared equals negative 4. Now we can take the square root of both sides to get rid of that squared. But remember, if we do the square root of both sides, we have to include the plus or minus version of the answer. Every time we take the square root, don't forget to do the plus or minus version, just like we did in example 1. So we get x equals plus or minus square root of negative 4. Well, what's the square root of negative 4? Well, this is going to be, so we can break it up into plus or minus square root of 4 and then square root of negative 1, right? But we know that negative 1, the square root of negative 1 is I, right? So, and we know that square root of 4 is 2, so this becomes plus or minus 2I. And that's our guy. All right, so I'm going to give you one more mini example just to make sure that you kind of get how to do this. So let's look at just another mini example. So 3x squared minus 5 equals, equals 20. Equals 0. Okay, so then if we want to do this, well, we have to add 5 to both sides. So we had 3x squared equals 5. Divide by 3 on both sides. And we get x squared equals 5 over 3. Now we can take the square root, don't forget the plus or minus square root of both sides. So we get x equals plus or minus square root of 5 over 3. Now, we could rewrite, if we were to write this as square root of 5 over 3, we have to rationalize that denominator, right? And if you guys don't remember how to rationalize the denominator, I can show you how to do that real quick. So what you do is you want to rewrite this as square root of 5 over square root of 3. Now, this is a skill that you may have picked up in Algebra 1 or so, or in another class. But I'm going to show you how to rationalize in case you don't remember. What you rationalizing is getting rid of that radical in the denominator. If you want to get rid of the radical in the denominator, you're going to times by the same thing on the top and the bottom. Okay, it's very simple to do. You just multiply by the same thing top and bottom from the denominator. Now, 5 times 3 is 15, so this is going to be square root of 15. And then 3 times 3 is 9, so this can be square root of 9. But we know that square root of 9 is 3. So the final answer, to be simplified, technically speaking, is square root of 15 over 3. All right, so that's how you rationalize the denominator. Both of these are answers, but sometimes they'll write it in this form. All right, go ahead and try the following problems, and we will cover them in just a little bit. All right, so let's go ahead and do the problems. We're not going to do factoring. We're just going to do the regular square root method because that's easier in this case. So subtract 49 on both sides. X squared equals negative 49. Now we take the square root, again, remembering to do the plus or minus version. So we get x equals plus or minus. We can break square root of 49 into square root of 49 and square root of negative 1. And then square root of 49 is 7, and then that's just going to be I. So 7i. So we got two answers, positive 7i negative 7i. For this one, subtract 25 on both sides. 9x squared equals negative 25, divide by 9. So we get x squared equals negative 25 over 9. Just leave that as a fraction. Take the square root of both sides. So now we got x equals. Now if I see a negative there, I'm automatically going to just put an I. Okay, so we know it's going to be imaginary. And then we got to do square root of 25 over 9. Well, what's the square root of 25? The square root of 25 is 5. And then the square root of 9 is 3. So this becomes 5 over 3i. And then I can't forget the plus or minus. That's all there is to it, guys. Now, the next lesson we're going to cover is going to be completing the square. So we're going to be covering other methods for solving quadratics.